Assalamu alaikum. How are you, my dear students? Hope you will be fine and okay. I welcome you all into my today lecture. Today lecture is PN junction or PN junction diode. PN junction diode is very important electrical component and which is used in various electrical or electronic circuits. So let us start with the name of Allah Almighty. Bismillah ar-Rahman ar-Rahim. So the first topic, the topic is the PN junction or the PN junction. Sometimes it is also called the PN junction diode. Now, what is the PN junction? The PN junction is that when a p-type material is suitably, when p-type material or substances, is suitably joined with n-type substances, joined with n-type material or with n-type substances, with n-type substance, resulting in arrangement known as PN junction, resulting a device or arrangement known as the PN junction or the PN junction diode. As you see here, the PN junction or the PN junction diode, as you see here in the diagram. Now look at this diagram. Here you have the n-type substances and here you have the p-type substances. So when a single silicon crystal is grown with n-type material, is doped with n-type material impurity at one side and p-type material or impurity at the other side, then this will result a PN junction known as the PN junction diode. Here in the PN junction diode, what actually we have, that if you remember, I told you that both the P and the N type substances, the N-type substances, both the substances are electrically neutral. Electrically neutral. If you remember, this is what I told you in the previous lecture, that they are what? Electrically neutral. So what happens here in the PN junction diode, that we actually disturb the electrical neutrality. Yeah, simple, I would like to say that neutrality is disturbed. Here the neutrality is what? Disturbed. They no more remain neutral, right? And this is why, because when you combine or when you form the PN junction diode, then here you know that we have the excess of electron here. That is the current carrier or the free electrons. So free electrons are in excess here. And here we have what? Here we have the holes are in excess. So at the junction, the holes and the free electrons diffuse across the junction, right? So this is why that some of the free electron will cross into the PN or to the P side, leaving behind a positive charge layer here and a negative charge layer here. Now the that is the first, I just want to tell you about the thickness of this PN junction here. This is called the width, this one. the here the width of the junction, the width or the thickness of the junction. So this width or the thickness of the junction, this thickness, the thickness or the width of the junction is nearly 1 micron, right? And this width of the junction, one important point which I would like to tell you, is inversely proportional to doping. The greater the impurity, right? Doping is the deliberate addition of impurity, right? So the greater this impurity, the smaller will be the width size, right? This is the, it is just long story short, I would like to tell you that PN junction is very much similar, or I will use the word equivalent to a capacitor. What to? A capacitor. It is just like that. Where in the capacitor, there is what dielectric between the two plates. Here, the dielectric is this width of the junction or this depletion region. It is called depletion region because this region contains no free electrons or holes. Right now, let us see that what happens here. I just want to explain this to you. Let us start, for example, if I just choose some of the free electron, for example, you know that we have the free electron, and I would like to represent the free electron by this red arrow. Like we have these, the free electron, as you see here. Let us, you see that we have the free electron, while I will denote the holes here with the vacant side by these blank circles, right? Like this one. Now, what happens that during the formation, right, some of the free electron, they cross into the p side, right, where they have greater what affinity for the free electrons, right? They are the donor, as you know, I told you that they are what, the donor. And when I was explaining the p-type substances, I told that they act like acceptor. So some of the free electron, they cross from the inside into the p region, so leaving behind net positive charge. So as you see that when they cross, look, when the free electron cross into the holes, for example, like this, they arrive into the hole, they arrive into the hole. So what happens that at the junction, there develops what? There develops a positive charge layer at the inside, positive charge layer, while the negatively charged layer develops on the p side, just like as you have seen in a capacitor, positive, negative, with there was a dielectric. Now this region, that is, once the positive and the negatively charged layer develop across the junction, the positively and negatively charged layer, this is a negatively charged layer, negatively charged layer, and this is the positively charged layer, the positively charged layer. You see here, there is a clear demonstration. Now, this diffusion will continue until that once the positive charge layer is developed here and the negative charge layer is developed here, the diffusion of the electrons, the free electrons from N region to the P region stops because of the potential barrier, we call that is at the junction, at the at the junction at the junction there develops at the junction there develops a form at the junction there form or a potential barrier. Potential barrier. This potential barrier, it stops the diffusion of the free electrons from n side to p side anymore. And this potential barrier, it is the potential barrier is 0.7 volt for diode made of silicon, and it is zero point 0.3 volt for the diode RPN junction made up of germanium. Okay, so this potential barrier does not allow the diffusion of the free electron from the N region into the P region. This is in this region here, which you see right now, like this region. This region here, as you see, and here it's like just this one, this region here. This region is called the depletion layer, or the depletion region. Why it is called this region? Because that it contains what? It does not contain, as I already wrote to you, that it does not that it doesn't contain any free electrons or hole. Why? Because of this potential barrier, right? The potential barrier, which can be increased or decreased, right? So in one way we can say that the PN junction diode, this make the PN junction diode, there is a kind of two-way switch, the PN junction diode. This PN junction diode can act both ways, can act both ways, as insulator as well as conductor. Depends upon what? And depending on the width of the junction. Depending on the width of the junction. Depends upon what? Depends upon the width of the junction. Now you see that, look, this is what we, as I told, that we call it the potential barrier. This one, as you see here. Now look, once this potential barrier is developed, then electrons are no more able to cross from N side to the P side. Why? Because the positive charge layer wouldn't allow the electrons to cross the depletion region. And similarly, the negatively charged layer will push the electrons back towards the inside, so not allowing to cross. So this is why we say that there is a potential barrier which stops the diffusion of the electrons from in region. Let us see that, see here, this, there is the width of the potential barrier. As I told, we call this the width of the potential barrier. This width of the potential barrier is changeable, or you can say adjustable, right? Now look, that is normally for the silicon, as I told, this potential barrier is what? It is 0.7 volt. It is how much? 0.7 volt. And for the free electron, it is very difficult to cross from what? To cross from the N region to the P region. Now we use two terms which I would like to explain to you. the one for the PN junction, the most important point regarding the PN junction. Reverse biasing, yeah, bias, reverse bias, or reverse biasing, and another one, the forward biasing. Normally, now look, what is the reverse bias? I'm coming to that point. Here you see, this is the this is the diode or the PN junction diode. See here, and here we have this is the electronic symbol of the diode here. This is the electronic symbol for the diode. This is what? This is the electronic symbol of the diode. Now this is the P side, right, as you see, and this is the N side of the diode. Now what is called this, the P side or the N side of the diode? Let us see. For example, that is once when the diode is formed here, there is two electrodes are projected out on each side of the diode. The one on the N side and the other on the P side, and the entire assembly is cased inside a glass seal. Right, this terminal we call the anode of the diode. Anode. In this terminal we call the cathode of the diode. Now, as I told, that the potential barrier is 0.7 volt. No electron can cross the junction in their normal condition. Now, let us see that as I told that now look, this is the anode, the inside, the cathode of the diode, this terminal, cathode. Here you see, this is the cathode, and here you see, this is the anode. Now in the normal condition, in the reverse biased condition, what happens, this is a kind of condition where the cathode of the diode, when the cathode of the diode is connected with the negative terminal, with the positive terminal of the battery terminal, while the anode is connected with the negative terminal of the battery. The diode is said to be in reverse biased condition. In the reverse biased condition, the diode does not conduct electricity. Diode does not conduct current, or does not conduct electricity. Why? It is because of the fact that, as you see here, look, once it is in the reverse bias condition here, as you see, what is going to happen? The depletion region, or the width of the depletion region, this is, as I told, the width, it increases, right? Here you just see, look, from the normal, look, this is what, this is the potential barrier which exists, point, as I told, 0.7 volt for silicon. Now you see, look at the normal condition. This is the width of the depletion region. But in the reverse bias condition, as I told, that when the cathode, this is the cathode of the diode, and this is the anode of the diode. So when they are connected with the anode with the negative terminal of the battery, and the cathode with the positive terminal of the battery, then the width increases. Why? Because you know that here it is connected with the positive terminal of the battery. So what happens? All the electrons will be attracted towards this end. For example, all the free electron, and it has what, this is the negative terminal. So you just see that either it will supply free electron or other way, which is not a correct statement, but because the holes are always fixed, they are the vacant side, they do not move. But for simple or for the easier understanding of the situation, I would like that the hole will sense, the hole acts just like the acceptor, right? So all the holes, they supposed to be attracted towards this end. Right now you see that what happens then the, as a result which the width of the junction increases and there is no flow of current, and in this case we see that the diode does not conduct current or electricity here, and we say that it is in the reverse biased condition, right? And here the diode acts as an insulator, acts as insulator, acts as insulator, and that is the resistance is of the order of, the resistance of the diode is of the order of few mega ohm, right? So the diode purely acts as the insulator or the PN junction. Contrary to this, we have the forward biased condition, forward biasing, forward biased. In this sort of situation, what is going to happen? That the anode is connected, the anode of the diode is connected with the anode of the diode is connected with the positive terminal of the battery, while the cathode with the negative terminal of the battery, negative terminal of the battery. In this case, the diode acts as a conductor. Diode acts as a conductor and allow the flow of current, allow the flow of current. As I told, there the width of the junction, as I told here that the width increases, right? In this situation here, width increases. The width of the junction increases, and here what happens? The width of the junction decreases. The width of the junction decreases. Okay, and that is the resistance in this scenario. The resistance of the diode is of the order of few ohm, order of few ohm, right? Very small resistance, and it is just opposite to the previous case where the resistance was very high, right? Look at the forward bias condition. In the forward bias condition, what happens that if you just see, look, this is the negative terminal of the battery, the positive terminal of the battery, as you see. and this is the negative terminal of the battery. So as I told that it is the cathode of the diode, cathode, and this is the anode of the diode. Now you know that look that it is connected with the positive terminal of the battery. So what happens here that the holes are pushed towards the junction while the electrons, the free electrons are also pushed towards the junction. Why? Because like charges repel each other, and what happens as a result with the width of the junction decreases here in this case, just opposite to this case here. In this case, what was happening to the width of the junction? Here the width was increased. For example, if this is the normal width, then in the reverse bias, this width increase enormously. And contrary to this, here what happens if this was the normal width, like here for example, the normal width like this one. Okay, so after the forward bias situation, the width decreases considerably. This is the forward bias case. This is for the normal. And just like this is it is for the reverse bias condition. So in this case, the electron, the free electron would gain much energy and will cross or will diffuse across the junction, right? And what happens that the flow of current will begins like this, right? That is the current will start flowing if I just use conventional way of current. Okay, so this is how you can see that the diode can conduct when it is connected across the terminal of the battery in one way, and the diode does not conduct while it is connected with the terminal of the battery in the opposite way. So if I just draw the graph between the voltage and the current for studying the IV characteristic, for example. So look, in the forward bias condition, that is the, if this is the forward bias condition, what happens right in the beginning, if this is the voltage and if this is the current. So right in the beginning, as the voltage increases, the current does not increases until the voltage reach a value of 0.7 volt. Once when you increase the forward voltage, then what happens? Then the current begins to increase, increase, and increase. If I just take it in the milliampere. On the other way, this is, let's say, for example, in the milliampere. Here, with the same graph, I will use it like this one, microampere. This is for the forward bias condition. Now, for the reverse bias condition, the opposite happens. And what is that opposite? That in the beginning there is a little or small current, right, due to the thermal electrons present at the junction. And after that, when you increase the reverse current, increase the the reverse voltage, right? The current does not increase as you see. This current is only as right now, which you see a that small current, it is only in the micro ampere in the beginning. And then for further increase in the bias voltage, the reverse voltage, right? The current does not increase until we reach a value called the saturation current, right? Called the breakdown voltage. Sorry, this is called the breakdown voltage. At this breakdown voltage, the diode gets permanently damaged, right? And what happens? That it conduct current, right? It just becomes a good conductor, right? If you increase the reverse potential more than the specified value, right? More than the breakdown voltage. Okay, and that is the current is then said to be the saturation current. So this is the reverse bias condition. So in the reverse biased condition, the diode does not conduct, while in the forward bias condition, it indeed. So this diode is used in many electronic instruments. For example, here we use the diode, we have the various types of this p-n junction diode. For example, light emitting diode, the LEDs, which you have seen, right, or which you see, for example, just like the charging indicator of your smartphone, that is light emitting diode, and the electronic symbol for the light emitting diode is this one. There is a photodiode. Photodiode is the diode which conducts when the light falls on it, as you see here. And this is usually the photodiode is used in the LED is used in the remote control, while photodiode is used in the television to receive signals from the remote control. And we have here the laser diode also, as you see it here. So there are various types of diodes, and it is, has various applications. So this is the end of our today topic. So inshallah, see you tomorrow in the next lecture. The next lecture will be rectifier, which is a device used to convert alternating current into a direct current. So thank you very much.